Let's continue practicing our decomposition skills looking at Objective 6. We're going to predict products of a decomposition reaction using what we call our helpful hints. On the bottom of the combos, we learned that there were 5 helpful hints to learn how to break a single reactant into many products. What makes a decomposition unique is it is the only of the patterns to have a single substance breaking down into simpler pieces. So we'll have just one reactant. When we look at number 1, phosphorus acid, we're expected to learn how to write that as an acid. We know that acids always start with H, so I begin that just by writing H with its +1. OUS told me that the original polyatomic ion came from ite, so I use my polyatomic ion chart and find phosphite. PO3 with a -3 charge. So H with a +1, PO3 with a -3, and we get H3PO3. This aqueous acid is heated and forces it to decompose. What helpful hint is going to help us in predicting how this oxyacid is going to decompose? My eyes go right here to number 1. When oxyacids are heated, they decompose to form water and the nonmetal oxide. There are 3 steps in predicting how to break down an oxyacid. Step number 1, subtract the water. Let's do that first. When I break down an oxyacid, that's the kind of compound this is, H3PO3, using helpful hint 1. Step 1, remove the water. When I remove the water, the first of my products, H2O, it then tells me on my helpful hint page to balance the hydrogens. Balancing the hydrogens means using coefficients, let's get the H's working. If I have 3 on the left and 2 on the right, we need to turn them both into 6s. I know that I need to double the left side and place a 3 in front of the water, giving me the H's each at 6. So after subtracting the water, I then use coefficients to balance the hydrogens. And now I'm ready to subtract to find the subscripts on my nonmetal oxide. I subtract to find the subscripts on the nonmetal oxide. P something, O something will be the bare bones of our nonmetal oxide formula. Notice that coefficient of 2 tells me that there's 2 phosphorus. 3 times 2 tells me there were 6 oxygens, but remember we've used 3 of the 6 already to make water, leaving me a remainder of 3. P2O3 is our nonmetal oxide. Helpful hint 1, when an oxyacid decomposes, take out the water, get the H's to balance, and then subtract to find the subscripts on your nonmetal oxide. Number 2, when solid magnesium hydroxide is heated, it decomposes. Magnesium hydroxide. Remember hydroxide, our polyatomic ion that represents a base? Hydroxide is OH-1. When I consider helpful hint 2 on my decomposition helpful hint page, metallic hydroxides, when heated, decompose to form the metal oxide and water. The metal, of course, in our problem was magnesium. Magnesium hydroxide will turn into magnesium oxide and water. Think charges, it says on my helpful hint page. When magnesium hooks in a compound, we know it carries a +2 charge. Hydroxide is our polyatomic ion, the base ion, that carries a -1. When magnesium hydroxide is heated, it decomposes. The metal hydroxide turns into the metal oxide. The metal oxide is magnesium oxide and water. This equation, when it decomposes, works out to be balanced. The hydroxide is the base. When metallic hydroxides are heated, out comes the metallic oxide and water. Hooking by charge, we end up with a balanced equation. Number 3, the white powder of aluminum chlorate will when heated, will decompose. Remember the polyatomic ion chlorate, ClO3 minus 1. Chlorates decompose upon heating. When aluminum is in a compound, it will hook with a +3 charge. The polyatomic ion chlorate is a -1, so the initial reactant, AlClO3, taken 3 times. It will decompose upon heating. Now carefully examine your helpful hint page. Anything there about chlorates that will help me deduce how to break this down? You found it. It's number 4. Metallic chlorates give off metallic chlorides and oxygen gas. Read that with aluminum in it. Aluminum chlorate makes aluminum chloride and oxygen gas. And we've just now stated our skeleton, and remember to consider charges. The chlorate decomposes to form a chloride based on charge AlCl3 and oxygen gas. Elemental oxygen is written as O2. Then we go back and we balance. 1 aluminum, good. 3 chlorines, good. 9 oxygens, 2 oxygens. We have an odd-even problem. When I have an odd number, I double it. That gives me 2 aluminums. 3 times 2 is 6 chlorine. 3 times 2 is 6 chlorine. And 9 times 2 is 18 oxygens. 9 times 2 is 18 oxygens. A 2 to 2 to 9 balances that equation. I knew to double it because I had an odd number of oxygens. We'll try number 4. Whoops, I forgot to write down. Helpful hint number 4 guided me with the third of our equations. Now we'll read number 4. Solid sodium carbonate is heated in a test tube to cause its decomposition. The carbonate is a polyatomic ion, carbonate, CO3, and it carries a -2. Carbonates is helpful hint 3. When carbonates are heated and they decompose, we get out a metal oxide and carbon dioxide gas. The driving force, bubbles of carbon dioxide gas. Metallic carbonates give me metallic oxides and carbon dioxide. The metal in our example is sodium. Sodium carbonate, Na2CO3, will decompose when it's heated to give a sodium oxide and carbon dioxide gas. Helpful hint 3 describes how metal carbonates release to form metal oxides and carbon dioxide gas. Again, this one worked out balanced. We'll try one more. Water is treated with electricity to cause decomposition. Water is a binary compound. It simply means it's a compound built of just 2 elements. Binary compounds were discussed in helpful hint 5. If compound AB breaks down into simpler pieces, it forms its element A and element B. The compound separates into the elements. Water is a binary compound. It's built of 2 elements. The elemental form of hydrogen, H2, and the elemental form of oxygen, O2. Helpful hint 5 says take a binary compound and separate it into its elements. The next thing we do, of course, is balance. 2 O's on the right makes me double the left, and I'll repair the H's. A 2:2:1 mole ratio. Each one of our helpful hints has been used. Notice that 1, 2, 3, 4, 5. You can count on that pattern for test day as well. Find your activities series next. We'll begin with some single replacements.